All right, guys, so we're going to talk about linear versus nonlinear. So we understand that this year we've worked on writing equations in slope-intercept form. So linear is anything that has a constant rate of change and can be written in the form of y equals mx plus b. Nonlinear cannot be written in that form. So while that seems easy, sometimes they can make it look like it's more complicated. So there's a couple things that you can pay attention to. So let's just look at some examples. First of all, you've seen ones like this. We know that that's linear. And then you may have seen something like this. Well, this, because it doesn't have the y, it's still linear. It is just a vertical line here, like this. It would be a vertical line where x is 5. So the thing with this one is it is linear, but this is not a function. It is the only line that is not a function. Oop, that did not go well. So let's try that again. Alright, so then you may have ones that just say like y equals 6. That would be a function. We know this is a horizontal line where y is 6 on a graph. I'm struggling to write this thing. Okay, so now they also like to do examples where they would say 2y equals maybe 6x minus 4. This is still linear because we can divide everything by 2 and still get it into this form of y equals. So this would be y equals 3x minus 2. So these are all linear. So let's just label these as linear. Now, we get into things that aren't linear, such as y equals x squared. So this makes what we call a parabola. It is a function, but it's not linear. It's not a straight line. You might have y equals the absolute value of x. This is not linear either. It makes a V shape. You might have y equals x cubed, and this makes kind of an S shape. All three of these are functions, they're just not linear. So we often get that confused. Linear just means a straight line. Like when you graph it, it would be a straight line. You may have other ones like x cubed, or not x cubed, I'm sorry, x equals y cubed. Or x equals y squared. That's one that most kids like to look at. That would go like this. Now, this one is not linear, but it's also not a function, remember, because it won't pass the vertical line test. Then you may have y equals 1 over x. This also would not be linear. Now, so this one is gonna lead me into the discussion of how to tell. Let's say that you forget what the graph of it looks like to tell if it's linear or not. It is linear as long as x and y are to the first power. You say, well, Ms. Rose, I don't see an exponent on this x here. Well, remember that x is in the denominator. So this can be written as y equals x to the negative 1. And this makes this nonlinear. You see here that this has x squared. This one has x cubed, so all of those would be nonlinear. You can't have, another one is the square root of x. You say, well, I don't see an exponent. Remember that square roots are actually exponents, so it's x to the 1/2 power. So again, the exponent on x is not 1, so therefore it's nonlinear. Now again, they like to make this look tricky too. They will say something like y equals x times x plus 2. Well, the problem with this is when we solve our equation and we distribute, this actually becomes y equals, and x times x is x squared plus 2x. Well, because I have the x squared there, this is nonlinear. So you really have to look at why these, after you simplify these, why these would be linear or nonlinear. And it all comes down to those exponents. Now, so there is what it looks like in a graph. There's what it looks like in an equation. But what about in a table? So I know that when we were grading the test and go over some of our practice stuff, this is what happened. So obviously if you have like 1, 2, 3, 4, these are kind of easy to tell. 6, 8, 10, and 12. We can say, okay, each time the y, or the change in y, is 2. And each time the change in x is 1. So this rate of change is constant. And because it has that constant rate of change, this is linear. You're going to be able to find a slope. So this slope, or m, would be 2 over 1. So it has a constant rate of change. That slope is the thing that holds those coordinate points in a straight line. So you're looking for that. Now sometimes that can get tricky too. They like to leave out things and see if you can catch it. So like this might say 1, 2, and 5, and 9. And then they may put a 4 there. And so this would be 17. Well, you say, well, this goes up 4, and this goes up 2. And then this goes up 8, and then this goes up, or sorry, this went up 1. Sorry. And then this went up 2. Well, if we look at this, our slope, if we just look at the first 2 points, is 4 over 1. If we look at the second 2 points, you would get 8 over 2. Well, what is 8 divided by 2? It's 4 also. So this means that this also has a constant rate of change. And these two slopes are maybe proportional to each other. And so they reduce to the same thing. And so this is a linear table. So to find a nonlinear table, you're looking for something that might have like 2, 4, 6, 8, 3, 5, 9, 15. Well, this is going up 2 every time, but this goes up 2, and then it goes up 4, and then it goes up 6. Well, this is 2 over 2 here would be 1, and then 4 over 2 would be 2. So you don't get the constant rate of change. So this one is nonlinear. Okay, so we have to look at a table of whether the rate is constant or not. If we can get that constant rate, then it's nonlinear. So let's recap here for just a second. So if we are looking at a graph, we are making sure that we don't have the exponent on x or y. Absolute value here is nonlinear also, and we won't get into all that, but just know the absolute value is nonlinear also. The square, the x on the denominator, the square root of x, all those things are nonlinear. So the only thing that is linear are those things that have just x and y. It can have x or y, or it can have both, but it cannot, they have to be to the first power. Now again, don't get linear and nonlinear mixed up with function and non-function. Linear and nonlinear means, is it a straight line or is it not a straight line? You can have functions that are not straight lines. So let's review that one more time. For instance, this graph, which is a parabola, this is a function because it would pass the vertical line test. And it's y equals x squared. This is a function. It is not linear because it is not a straight line. So this would be called a non-linear function. Now, if they say to draw a linear function, that's pretty easy. They want you to draw a straight line that is a function. Well, there's only one straight line that's not a function. It's a vertical line. That's the only line that you can't draw. So you could draw this one, you could draw this one, you could draw this one. You just cannot draw a vertical line because it is a line, but it is not a function. So a linear function would be any one of those. You just can't draw a vertical line. All right, I hope that clears up some things.